So we're going to look at the factored form of the X transformations or the inside transformations. And this factored form is the way we want to be able to do things. Okay, so this is the easiest way and the best way that we can describe horizontal transformations. Now, it's important to understand that we cannot rely on this especially for this unit, because we may not be able to do it in factored form. But if we can, and the next units what we're going to do, we want to be able to use factored form. Okay, so factored form is important, but we cannot rely on just this using the factored form. Okay, but it is an excellent way to do it. So when we do factored form, the factored form always is flip and expansion first, shift last. And the reason why the factored form is really good form to use is because when we shift at last, this P then gives us a good indication where the critical points are, or the vertices are going to be. So that's ideal. If we can actually see where our vertex is going to be in the actual equation, that's very useful for us. Okay, so we don't have to do a whole bunch of transformations to figure out where a vertex is. We can see it right in the equation. So the factored form is going to be a really good way to be able to do it if we can. So when I do factored form, so this is factored form here, I'm just going to show you. In factored form, when I undo factored form, okay, so it looks like this. This is my notation. Okay, and when I undo the factored form, I'm going to undo the times. So I'm going to end up with divide first and then plus. I'm going to undo the minus last. Okay, so it does this first, okay, when we transfer it over there, and the minus 3 is done afterwards. So we can see that our factored form is going to always do the shift last. Okay, so if we understand that, we can just leave it in factored form and not have to do all this undoing stuff. So when I see this, this is factored form. So my change in X then is going to be, first is going to be horizontal compression. It's still backwards. Okay, by half. And then secondly, it's going to be a horizontal shift, and it's minus 3, so it means that's going to be plus 3. Okay, so it's still backwards, but the order is fixed. We don't have to worry about order anymore. And we can see here, yeah, compress first, shift plus 3 last. Okay, and then the change in the Y, well, the Y never was a problem. Change in Y is going to be, it's a vertical flip first. It's going to be a vertical expansion by 5 times, and then it's a vertical shift plus 4, up 4. Okay, so this one here, if I were to undo this, I would end up doing shift to the right 12 first, compress last. Now, it's hard to keep track of the vertex if that's the case. So this is why, if we can write things in factored form, the factored form allows us to see the vertex point. Okay, it allows us to find the vertex point much easier if we have it in factored form. So once I factor it, this means I compressed first, then shifted to the right 6. So my vertex can be seen in the actual equation now. I know my vertex is going to end up at plus 6. So factored form allows me to do first my horizontal compression by 1/2 first. Second, it's going to do the horizontal shift plus 6 second. Okay, it's going to be able to do that last. Okay, so that's what we want. We want to be able to see our shift last so that we can see where our critical point or our vertex is going to end up at. So same thing here. Okay, this is not factored form, So if I were to actually do this, it's going to do shift to the left first, and then expand and flip last. But we want to be able to see where that vertex is going to end up. So I'm going to factor the inside of that, okay, and write it in factored form. So I'm going to have my coefficient, my compression and flip, or sorry, my expansion and flip. I'm going to take that on the outside. Okay, and once I put it into factored form, I'm going to be able to do this first, shift last. Now when I do the shift though, I'm going to factor the negative out of here, so it's going to be -4. Okay, and if I can double check that by multiplying that back in, and I get +2. So there's my factored form. And then I'll just do the +8 at the end. So once I have my factored form, I can express expand and flip first, shift last. Okay, so I'll do the y first. The y is easy. I'm going to do vertical expansion by 5, vertical shift up 8. My change in x, okay, the first thing that's going to happen is, since it's factored form, it only works, it doesn't work here when it's not factored, but once I factor it, I'm going to have my horizontal flip, I'm going to have my horizontal expansion by 2. Okay, divide means to do the opposite. We're still doing the opposite, but now our order is fixed. It's fixed as shift last. So I'm going to go to the right for last. Okay, so that the factored form sets the order, and the reason why we want to do that is because now we can see where the vertex is going to end up being right in the notation. So as it gets more complicated, it's going to be a little bit harder to factor, but we can still do this by rearranging the expressions. Okay, so what I'm going to do first is I'm going to get rid of all these inside brackets. Okay, all that inside stuff, I'm just going to get rid of all these brackets. So I'm going to end up with negative x over 2 plus 3 plus 2. Okay, and then on the outside I have my -2. I still have to keep track of my inside and outside. Now this one I'm going to simplify and factor. So I have y equals f of, okay, so it's going to be negative x over 2 plus 5 minus 2. Okay, and then if I want to express this in factored form, I can then do the transformation as expand and flip first, then shift last. Okay, so the factored form, we have to be careful here. We're going to factor that coefficient out. So -1/2. I'm going to put the divide by 2 here like that. Okay, and that's going to be factored form as well. And then the inside is going to be negative. If I divide that by -1/2, I get -10. Okay, so -10 divided by -2 is going to give me my +5 that's in here. So those are equivalent. And it's written a little bit funny now, so some people like to write that 2 1/2 in front. That's perfectly okay, but sometimes you're going to see it like this. So I'm going to leave it like that. Okay, so that divide by 2 is factored form. Okay, so now my change in y I can describe fairly easily. It's going to be vertical shift down 2. Now my x's, because it's in factored form, it's going to be shift last. Okay, so I'm going to do change in x. The first step is the horizontal flip. Okay, we could have done the compression, the expansion first, but these two are reversible. So it's a horizontal expansion. And it's going to be expansion by 2. Okay, remember, still opposite. Divide means to expand. And then The minus 10 means that's horizontal shift plus 10, because remember it's still backwards, but the order is fixed as shift last. Factored form means shift last. Okay, so same thing here. I can just simplify this expression. Okay, so I'm going to simplify this expression into so that I can combine all the terms into here. Okay, so I'm just going to make sure I keep track of my outside. That's my outside. In fact, I'm going to do my shift last for my y's as well. So I'm going to get rid of those brackets. So I'm going to multiply that 3 in. So I get f of blank. And it's going to be minus 6. So 3 times negative 1 is negative 3. 3 times negative 2 is 6. So I'm going to do my shift on the outside last as well. Okay, because that makes it a little bit easier as well. So the inside then, I'm going to get rid of these brackets. So I'm going to get negative 2x over 3 plus 1. 3 over 3 is 1 minus 1. Ooh, conveniently those cancel out. So then, rewriting this, I get y equals negative 3. Okay, there's my vertical transformation. This is just going to end up being negative 2/3 negative 2 over 3 x. And I can do that. It's in factored form. I don't really need those brackets, but I just want to emphasize it's in factored form. And there's my y transformations. So my change in y's, there's more things going on with y's here. So my change in y is going to be a vertical flip. It's going to be a vertical expansion by 3. It's going to be vertical shift down 6. Those are my vertical transformations. My horizontal transformation, okay, there's a flip and an expansion by 3 over 2. Remember that's opposite still. So I'm gonna do the expansion first. So it's gonna do horizontal expansion. Again, remember it doesn't matter if I do the flip or the expansion first, but I'm gonna happen to do the expansion. It's gonna expand by the reciprocal 3 over 2, okay, or expand by 1.5 first, and then it's going to do a horizontal flip. Okay, and algebraically, it doesn't matter which one I do first, so I can switch those around if you really like. Okay, so then the last thing is I have, if I want to, given the transformation, and I want to write it into function notation with my shift last, I can always expand. So in this case here, let's read the transformation. It's a horizontal flip, horizontal translation, horizontal expansion by 2. This is not shift last. Okay. However, I can always put it into shift last form after I rearrange it. Okay, so I'm gonna say here, okay, so this is the do part of it. This is my description, what I'm actually gonna do. To calculate x new, I'm gonna do a flip first, plus 3, plus 2, and times by 2. Okay, so that's what it looks like algebraically. So I'm going to actually do this last. But I could really arrange this so I can do my shift last. And all that would really take is, that would mean taking out the brackets. So this is not my notation. Okay, this is definitely not my notation. But it's telling me I do shift last. Well, I think maybe we can work this out. Now I'm taking a shortcut here, but I think if I know this shortcut well enough, I think I'm okay taking this shortcut. So we're saying this is, I'm gonna expand, flip, and then shift last. Well, that means it must be in factored form. And it must mean that my shift of -4 or +4 is happening last. So there's my shift last. It's in factored form. I'm going to expand and flip. So expand and flip looks like that. Okay, so that should be the correct function notation. Now, I better double check this because I have a way to check this. So if I were to convert this into its notation, I just solve for the other x. So I'm going to do -4 first, divide by -2 last. Okay, there's my notation. That notation matches that notation. So if I'm not sure, I can always use this process of undoing to be able to get my notation. However, if I have it so that it's described as my shift last, the factored form is perfectly fine to use in that situation. We have to be fairly confident with this and understand what's going on. If we don't know what's going on here, we really should rely on this undoing process because this is much more reliable and allows me to accommodate much more complicated transformations. But if we can, and later on we're going to try doing everything as shift last because that is definitely the easier way to do things.